Okay, so we are going to start reviewing for our quiz on graphing quadratics in standard form. So we've been working on that for the last 2 days. And there's one other thing that we kind of need to look at. We haven't looked at anywhere they're maybe mixed up or they're not in standard form. We have to put them in standard form first. So just to review, standard form is when you have the y by itself on one side of the equal sign, and then you have ax squared plus bx plus c, so there are no parentheses or anything like that, and you have your x squared term first, your x term second, and your constant at the end. So first thing we want to do is make sure that the equation is in standard form, and then we'll go through the steps for graphing. So if we take a look at number 1, it's already in standard form. The y is by itself. And we only have an x squared term here. So the a is -1/2, but the b and the c are both 0. Now, hopefully you remember that when we went over this, when that happens, and you use that little formula, -b over 2a, to find your axis of symmetry and your vertex, when your b is 0, 0 divided by anything is 0, so your x is just going to be 0, which means your axis of symmetry is 0. So when you go into that formula and you do -0 over 2 times -1/2 or whatever, it's just going to be 0. So your vertex will be 0, comma, and then what do you get when you put a 0 in for this x? Well, if you do -1/2 times 0 squared, 0 squared is 0, and 0 times anything is still 0. So your vertex will be 0, 0. So now when we go to graph that, we have 0, 0, which is at the origin. We have our axis of symmetry, which happens to be the y-axis in this problem. And then if we remember, we did our graphing pattern, which was that a value times 135. So if I multiply that, I have -1/2, -1, and -2.5, or 2.5. If you have decimals, that's totally fine. So from my vertex, I'm going to go down 1/2 over 1, then down 1 over 1, and then down 2.5 over 1. And notice when I went down 1/2 over 1, I was in the middle of that box. So then when I had to go down 1, I was in the middle of the next box. And then down 2.5 was 2 full boxes in that remainder of that one. Same thing on the other side of the axis of symmetry. And then this would be what my graph looks like. Now, you might notice, okay, well, this here says roots. What does that mean? Well, roots is another word for solutions or x-intercepts. So remember, we did talk about x-intercepts when we did the intercept method. So it doesn't matter what form your graph is in when you graph it, or your equation is in when you graph it, but there still can be x-intercepts. And those are the points on the x-axis where the graph crosses through or touches. So in this example, there is only one, and it is 0, or 0, 0, you could say. That's the only point where this graph comes into contact with the x-axis. So that would be your root. There's one root there, which is just 0. So you could even just say it's x equals 0. Okay, so let's take a look at the next example. So the next one, we have an equation. The y is by itself, and there are no parentheses, so it looks like standard form. The a is the number in front of the x squared, which would be 2. The b would be the number in front of the x, which we do not have here, so b is 0. And c is the constant at the end, which in this case will be -8. So when we go to do our formula to find x, we're doing -0 over 2 times 2, and 0 divided by anything is just 0. So x equals 0 is the axis of symmetry. It's also the first part of the vertex. So now when I want to find my y, I have to do 2 times 0 squared minus 8, which just gives me 0 minus 8, which is -8. So when I go to my graph, I want to plot 0, -8, which is, let me see if I can move this down here. Oh. And my axis of symmetry is that y-axis because that's our line there. And then we want to do the graphing pattern. So the graphing pattern is going to be 2 times 1, 3, 5, which is going to get us 2, 6, and 10. So from this point, I'm going up 2 over 1, up 6. Oh, wait, I didn't quite go over 1. It's a little hard to see on this graph. So up 2 over 1, up 6 over 1, and then I would go up 10 over 1. Same thing on the other side of the axis of symmetry. And then this is what that parabola is going to look like. Now, as you probably remember, here's our two intercepts, -2 and +2. So those are also known as roots. So x equals 2 and x equals -2 would be our two x-intercepts or roots. Of course, as far as this is concerned, our vertex is a minimum because it's the lowest point on the graph. Now remember, domain and range. Now our domain is all real numbers, and our range is the y's are all going to be greater than or equal to whatever this lowest y is. Now I think yesterday's notes, I forgot to put the equal to's on there, so I corrected it on the notes that I attached to PDF, but in the video I just said greater than or less than, I didn't say equal to. So just make sure that you have that little line on there. So if we're looking at the first one here, the domain is all real numbers, and the range would be all the y's are less than or equal to that 0. All right, so moving down, we will go ahead and do number 3. So our A is 1, our B is 4, and this time the C is 0 because there's no number adding to the end. So when I go to find my x, I have -b over 2 times A. -4 over 2 is -2. So x equals -2. So now I'm going to find out what is my y. So -2 squared plus 4 times -2. So -2 squared is 4, and 4 times -2 is -8, and then that gives me -4. So -2, -4 will be my vertex. We know it's going to be a minimum because it's opening up. And then I'm going to use my graphing pattern of 1 times 1, 3, 5 to get the other points. So starting at -2, -4, my axis of symmetry is the vertical line going through that vertex. And my graphing pattern is up 1 over 1, up 3 over 1, up 5 over 1. Same thing on the other side of the axis of symmetry. And there's my parabola. Now again, we want to know what the roots are, or the x-intercepts. So where is this parabola intersecting the x-axis? Those are the x-intercepts or the roots. So x equals -4 and x equals, let me fix that so it looks a little better. X will equal -4 and x also will equal 0. So if you remember back to the factored form or the intercept form, we use zero product property to find those two intercepts. This is just, we're just picking them out off the graph. Okay, and now we're going to go to number 4. So this one is in standard form. It has an A, B, and C. So A is 2, B is -8, and C is +6. So to find our axis of symmetry, we're going to do -b, and because the b is already a negative, that's going to become a positive. 2 times a, and 8 divided by 4 is 2. So our axis of symmetry will be x equals 2, and the vertex will start out with a 2. So when I plug in that 2 for x, I want to find my y. So 2 squared is 4, 4 times 2 is 8, 8 times 2 is 16, plus 6. So -8 plus 6 would be -2. And then I'm going to use my graphing pattern, which will be 2 times 1, 3, and 5. So 2, -2 is my vertex. My axis of symmetry is the vertical line x equals 2. And my graphing pattern is 2 times 1, 3, 5, which will be 2, 6, and 10. So I'm going to go up 2 over 1, up 6 over 1. And if I could fit it, I would go up 10 over 1, which is a little bit off the graph. Same thing on the other side of the axis of symmetry. And then you can draw the parabola. Now, once again, what are my roots? Where is this parabola intersecting the x-axis? It is at 1 and 3. So the roots will be x equals 1 and x equals 3. Now, once again, as far as domain and range is concerned, the domain is always all real numbers, and the range, if the graph is opening up, y is greater than that k value, or that c value, greater than or equal to -2. For this graph over here, our domain was all real numbers, but our range was y is greater than or equal to -4. Okay, so now on the next page, we're going to do the same thing, but we need to put it in standard form first. Okay, so you might notice that the equal signs are kind of like in the middle. So we need to get it so that it's y equals. So we're going to rearrange it first. So if I want to bring my -9 over to the other side so that it's x squared plus 6x plus 9, when you bring it over, it changes signs, then you can put your y equals or equals y on. It doesn't matter which side you put it on. So that's the first step you have to do. So get that y by itself. And we had done that back in chapter 8 when we did some factoring and things like that. So this isn't the first time you've done something like that. Okay, once you get it into standard form with the y by itself and everything on the other side, now you can go through the same steps. Identify a, b, and c. Find your x, -b over 2a. So x is -3. Now we want to find the y value. So I'm going to do -3 squared plus 6 times -3 plus 9. 9 minus 18 plus 9 is 0. And then I'm going to do my a value times 135 to get my graphing pattern. So starting at my vertex, which is -3, 0, my axis of symmetry is the vertical line, x equals -3, going through that vertex. My graphing pattern is 135, so we're going to go up 1 over 1, up 3 over 1, up 5 over 1. Same thing on the other side of the axis of symmetry. And then there's your parabola. Okay, and then we just want to point out what are the roots, and the root or roots is the spot where it's going to intersect that x-axis. In this case, there's only one, x equals -3. Okay, our domain, all real numbers, and our range, y is greater than or equal to 0. All right, so let's do the next one. Okay, so we got to get this 3 over to the other side. So this will become -x squared plus 2x minus 3. And then I can just stick my y equals on there. So now my a is -1, my b is +2, and my c is -3. I'm going to use the formula -b over 2a to find my x. So I have -2 over -2, which simplifies to +1. And then I'm going to plug that +1 into my original equation for x in both spots. Make sure you use parentheses. And I'm going to have -1 plus 2 minus 3, which is going to give me -2 for my y. So now my vertex is 1, -2. My graphing pattern is -1 times 135. So I'm going to be going down when I graph. So 1, -2 is my vertex. My axis of symmetry is the vertical line, x equals 1. And then I'm going to use my graphing pattern, which was down 1 over 1, down 3 over 1, and then down 1, 2, 3, 4, 5 over 1. Make sure you do the same exact thing on the other side of the axis of symmetry. And then there is your parabola. Now this one's interesting because it does not cross the x-axis. So as far as roots or x-intercepts are concerned, there are none. So sometimes there are not any. And that is an example. The domain here is still all real numbers, and the range is still going to be y is less than or equal to the y value on your vertex, which is -2. All right, and I think that's about it. Okay, so basically the last 2 days we went over how to graph quadratic equations in standard form. We talked about all the different parts, which we've been referring to even with the other forms. We talked about axis of symmetry, the vertex. Is the vertex a minimum or a maximum? What are the roots or the x-intercepts? All those different things. Also, make sure you can identify y-intercepts as well. So like on this graph here, the y-intercept would be 0, -3. On this graph, the y-intercept would be 0, 9. And you might notice that that is the end here. So -3, whatever that c value is, that was also your y-intercept. So on this page, your y-intercept was 0. We had a c value of 0. On this one, our y-intercept was 6. We had a c value of 6. On the first one, and the first one, the c was 0, y-intercept was 0, and on this one, the y-intercept was -8, and that was also our c value. So that also gives you some information as well. So hopefully that helps you guys out. We do have the meetup today at 10:30, so if it's not 10:30 yet, please check in and ask any questions. And then Monday will be your day for the quiz. And then we will move on. And hopefully you guys enjoy your weekend. Have a great day.